Layer 2 is a collective term for solutions designed to help scale up an application by handling transactions over layer 1, such as the Ethereum mainnet, while taking advantage of the robust decentralized security model of the underlying layer 1 mainnet. Transaction speed suffers when the network is busy, which can make the user experience poor for certain types of decentralized applications. And as the network gets busier, the gas prices increase as transaction senders aim to outbid each other. This can make using Ethereum or any other programmable blockchain very expensive. One solution for that are rollups. Rollups are solutions that perform transaction execution outside the main Ethereum blockchain layer 1, but post that transaction data back on layer 1. As transaction data is already on layer 1, this allows rollups to be secured by layer 1. Inheriting the properties, especially security properties of layer 1, while performing execution outside of layer 1 is a defining characteristic of rollup. Three properties of rollups are: 1. Transaction execution is outside layer 1. Data or proof of transactions is on layer 1. A rollup smart contract in layer 1 that can enforce correct transaction execution on layer 2 by using the transaction data on layer 1. Rollups require operators to stake a bond in the rollup contract. This incentivizes operators to verify and execute transactions correctly. Why are they used for? 1. It reduces the fees for users rapidly. 2. Open participation. 3. Fast transaction output. Now, there are two types of rollups with different security models. The first one is called a zero knowledge rollup, a ZK rollup. It runs computation off the chain and submits a validity proof to the chain. The second one is called the optimistic rollup. It assumes transactions are valid by default and only runs computation via a fraud proof in the event of a challenge. A ZK rollup or a bundle rolls up hundreds of transfers off chain, generates a cryptographic proof that that execution happened, called a SNARK, SNARK, succinct non-interactive argument of knowledge. This is known as validity proof and is posted on layer 1. The ZK rollup smart contract maintains the state of all transfers on layer 2, and this state can only be updated with a validity proof. This means that ZK rollups only need the validity proof instead of all transaction data. With a ZK rollup, validating a block is quicker and cheaper because less data is included. With a ZK rollup, there are no delays when moving funds from layer 2 to layer 1 because a validity proof accepted by the ZK rollup contract has already verified the funds. Being on layer 2, ZK rollups can be optimized to reduce transaction size further. For example, an account is represented by an index rather than an entire address. So the size of the transaction reduces from 32 bytes to just 4 bytes. Transactions are also written to Ethereum as call data, thereby reducing the gas a lot. Optimistic rollups sit in parallel to the main Ethereum blockchain on layer 2. They can offer improvements in scalability because they don't do any computation by default. Instead, after transaction, they propose the new state to mainnet or notarize the transaction. While optimistic rollups, transactions are written to the main Ethereum chain as call data, optimizing them further by reducing the gas cost. As the computation itself is low, the expensive part of using Ethereum, optimistic rollups can offer up to 10 to 100x improvements in scalability depending on the transaction. This number will increase even more with the introduction of shard chains. We talked about sharding already. This is because there will be more data available in the event that a transaction is disputed. Now, how do we ensure that disputing transactions is taken care of? Optimistic rollups don't actually compute the transaction. So there needs to be a mechanism in place to ensure transactions are legitimate and not fraudulent. This is where fraud proofs come in. If someone notices a fraudulent transaction, the rollup will execute a fraud proof and run the transaction's computation using the available state data. This means you may have longer wait times for transaction confirmation than a ZK rollup because it could be challenged. Now, I understand that this particular module was very tough to understand because of the entire new concepts being shown. So I request you to Google ZK rollups, optimistic rollups, layer 2 scalability, Ethereum blockchain, programmable blockchain. These 5 terms, you Google them and you read about them in depth, go to their Wikipedia pages, go to their official websites so that you understand the scalability factors in a much better way. Once you understand these scalability factors in a much better way, you will know which programmable blockchains has a very good feature, a very good future, and you'll know in which blockchain you want to invest in. The next module, we shall talk about decentralized autonomous organizations called the DAOs, the DAOs.